Okay, hi everybody. My name is Peter. I work at DESY. Don't know us. DESY is a high-energy physics, photon science, and accelerator research lab in the north of Germany. We're based in Hamburg and in Zeuthen. Zeuthen is near Berlin. We've got about 2,500 staff, over 3,000 guests a year. That's PhD students, researchers that come to do their experiments at our facilities. And these numbers are growing as we proceed in time. We've got three main accelerators on site. So that's the Tetra 3 ring and two flash accelerators that produce data right now. And coming up is the European XFEL accelerator dash photon science light source that will be producing some tens of petabytes a year. So we're approaching LHC numbers from their early days. Beyond photon science, we're involved in particle physics, both in LHC but also in BEL2, in the International Linear Collider project, and also in astroparticle physics, IceCube at the South Pole, and CTA, the Cherenkov telescope array that's being built up as we speak. And of course, another big machine we have is the computing infrastructure for LHC grid and our national analysis facilities. Just to put stuff in perspective, so the XFEL that you see starting here is actually a linear accelerator, some 3.5 kilometers underground, going out from our main site here. Okay. Computing. Historically, we've been very data-centric. DESY has always been the center of things happening. When we were running our own Hera accelerator, we were the tier 0. For photon science, we've always been tier 0. And essentially, that means data is produced, stored, processed, analyzed at DESY, always at DESY on site. Some of this data has been exported, of course, in the past, but mainly things were happening with us. And the computing we do is high throughput computing and HPC, so high performance computing for the different fields of study. We've always been used, and that's, I think, the theme back for the talk today. We're used to shepherding data and also taking care of its users. And in the last couple of years, data lifecycle management, we've heard it before, is getting more and more important just because we have more and more data. So it's more important to get rid of data that's not being used anymore. Our idea of scientific workflow has evolved from the past to something resembling this. This is a picture that Patrick Fuhrman has been showing for quite a while. We have this blob in the middle. In our case, that's of course Dcache, which is where we store all our data, our primary data at least. And in this case, we have some telescope data coming in, so high-speed data ingest into something. From there, it is used on the analysis facilities. It can be transferred worldwide. It comes in or goes out, either direction. And we've got our happy scientists as a spider in the web, doing whatever he does in his processing work and directing the bits to go wherever he needs them. Now, cloud storage isn't really something new. No? As we are talking, we all have our own cloud storage at our site. So it's a central storage, even if we call it cloud storage. We've had that before. FTP servers that we had in the past, AFS cells that we had, it's all a form of cloud storage. People can access it from anywhere in the world. They can take the data. But now people are asking for Dropbox-like solutions, so they want to have the idea that the data is local, they have it on their computers, or at least it has to feel like it's on their computers. Sync and share at the fingertips. Of course, we as an IT group have to act on that, so we try to do consultancy with our user groups. We train them. We go with them through projects that have to do with new ways of handling data. And what we try to do is, of course, also tell them something about data security, privacy, so make sure that if you share, you do it the right way around. Make sure that whatever you do is still understandable for the people whom you are providing the data for, while still being able to keep an overview of what you're doing in the long term. And by that, we think that we are working on increasing user acceptance for the offerings that we do, while at the same time we are learning about how these different communities take what they want, in what direction they want to move. And the last comment here with regard to cloud storage. So we've decided to phase quota out. Storage is unlimited. We can always provide as much as they need, because that has been historically the case. Every time a user says, I need more storage, we give them more storage. And enforcing that by quota just means that you create a lot of overhead for people having to ask, us to answer, do a lot of stuff. So what we turn to is reporting. What is far more effective than having a quota is creating a list and sending that to the head of the group every month. And that has actually turned out to be the most effective quota management that I've ever seen. All storage systems that I've put in the world in the last 15 years were, let's say, full fairly quickly in terms of quota usage. Here in our cloud storage, we see that people are really very careful with what they store for a long time. There's breathing space, but it kind of keeps in check. What does it look like? Well, as most installations, we've got load balancer on the front. We've got some front-end servers. In our case, that's OwnCloud for the production environment. And we've got this big Dcache installation in the background. Dcache is a completely different theme. I won't go into it today, but Patrick in the back can tell you for hours and hours on the top of Dcache. We use Postgres as a database, so we're not the MariaDB or the MySQLDB section. We've got this entire system tied into our user registry, so we have a central administration system that takes care of user administration, group administration, resource allocation. And that's fitted in there as well. There's a bit of numbers on usage, etc. And what I said before, at the moment we've got something like 14 million files in the DESY cloud. But we also had 30 million in the past. That was where people were experimenting. So they had their laptop and said, OK, let's sync root. That took a long while, but that didn't deter them. And after a long, long time, they managed to put in many, many files. But it's completely useless, of course, if you want to bring back your machine after your hard disk has crashed or something. So they turned to different means. OK. Beyond the production environment, we've got, of course, a development and test setup installed. Basically, it's a VM with Apache PHP, the stack that you need, and then n instances of our OwnCloud and nextcloud variants that we're testing and quality checking. Sorry. And that combined with the various backends that we have. So Dcache as our main production environment, but we also check against basic NetApp with NFS just to make sure how it works if you have a modifiable file system. We try to use it with Ceph or with S3 stores that we're testing routinely. That's where that fits in. For the configuration management, we're putting more effort in puppetizing the entire setup, making it perfect for our means at least. And the deployment management, so automating the scaling of front end dependent on current load is something that we're still working on. So if anybody out here has some good ideas on how you should proceed, I would be happy to talk to them at the break. Use cases. So there are some things that you expect, and we've got them here. So one colleague, he's a professor at DESY, he actually changed his entire work setup. He said, okay, if you provide me with a cloud that has high availability and high reliability, then I'm going to put all my data in there. He does away with all his different machines, his small file servers, whatever. He put it all in the cloud. So that's where we started sleeping very badly, because we were still in a pilot phase when he did that. And his mode of operations has been that in the evening he decides what themes he's going to work on the next day. And that is something he configures in terms of syncing directories. That runs overnight, and all his workstations that he's going to be needing, or his work group is going to be needing, are fed with the data that's due then on this next day. And as far as we hear, that's working quite nicely for him. It is something that you expect, that you hope for, but we didn't really expect people to jump in like this as he did. And he's been very helpful and valuable, of course, in creating feedback on what was working well and what was, let's say, worthy of improvement. Initially, all his data that we had was inserted via the NFS gateway that Bcache provides. That went smoothly. But then, of course, because of this file space database cache, you need to make sure that OwnCloud knows about the data in his file system. And that was something that really hurt, because he put in millions of files, and the sync processes weren't really capable of handling this kind of synchronization load. Other stuff that's happening is people really starting to share their data in accelerator research, for example. The Apraxia project is one where work package members actually put in, by syncing their research data, whatever it may be, while being able to have read-only access to the results of others in one single space. And of course, what we've seen is that many students have started using this for sharing this data with their proofreaders. That's always the arguments we get why they need access to the DESY cloud. In reality, of course, they have understood that this is a great way of having a second copy of something that they really, really, really want to have long term. Okay, so other use cases that we actually didn't really expect. So information workflow automation, that's a nice way of giving it a formal name. People on site started playing around. So their working groups have meetings. These meetings get notes. These notes are put into our Confluence system. They set up their own small virtual machine. By API calls, they get the meeting notes as a PDF, and they put the PDF in OwnCloud. And they make sure that all the VIPs in the working group have this folder as share folder, the sync folder, sorry, on their laptops. So every time somebody whizzes away on a flight to wherever. On the plane, he actually has his meeting notes, can go through them, comment, et cetera, et cetera. For them, it's working well. It was one of the scenarios where, for me, was kind of surprising. Another one, also completely unknown to us, the groups that are responsible for laying cables on the DESY campus started using it. So if there's work to be done, they go there, they take pictures, they make some drawings and drafts and whatever. They actually put all this data in DESY Cloud, and they use it for giving out tenders and stuff like that. When everything in terms of work has been finished, they do that again, and all this thing they've scripted into their cabling management workflow process. Again, something that you wouldn't expect. And the last one that you really, really wouldn't expect, of course, is people using this as a great site for travel photos. What we would like to do, let's say in the medium future, to implement things that Paul has been talking about yesterday. One of the words was quality of service. So we would like to give users a way to decide what kind of service level they actually need for some part of the data. So how many replicas of a certain file or directory do I want to have? Where should these replicas be? Should they be only in Hamburg? Should they be shared between Hamburg and Zeuthen? Or should we share replicated worldwide to some other site? Would I like to have my data on tape? That's something that we can easily do because our Dcache is connected to our tape libraries, so we can easily copy to tape as well, or many tapes if needed. And another thing, of course, information lifecycle management. What kind of data retention time do I require for the data sets that I put in DESY Cloud? For us, we need to work on defining our data availability offering. We do not do a classical backup of our cloud storage. So no TSM or Spectrum scale, whatever, running over it. No dumps. What we do is we make sure that we survive a disaster. So we're going to write all tapes to tape. We will always have them. And to be able to handle all these small files that we usually have in the DESY Cloud, we have this small files plugin for Dcache that actually puts them in containers and then ships them off to tape. We need to be able to say we never lose data, so preferably never delete the tapes. And let's say user land side, the user has his trash can. So let's call that self-service data recovery. You have your deleted files and its history in your own DESY Cloud folder. Things that we really, really, really would like to have. So have the metadata move into storage. We already have capable storage systems that have high-performance databases for file-space operations. We do not need a second database. And if possible, we would also like to put the sharing information in these file systems so that the underlying storage solution might even do the sharing internally also. We would like to find a better way of segmenting cloud storage in the sense of providing for scaling and performance tuning for different communities, let's say, better individually. Might be that this federation idea that we heard about yesterday will do the trick, but we'll need to see. I personally would like to see several storage backends combined under one cloud storage instance. So have my different instances of storage be available under one hood. Might mean a better abstraction of storage layer to accommodate for backend specifics, or in another way, have an awareness in the cloud storage solution regarding attached backends. And finally, of course, what everybody wishes for, I think, in this room is a better performance in sync implementation. Outlook, we will be looking at integrating our email and group stuff with OwnCloud so that we can have attachment handling handled better, or alternatively, not send attachments anymore by email, but provide a link in the cloud. Do better security handling, include stuff that we've heard about yesterday, of course. And all in all, and that's the most important thing, that's why I'm still talking, we are happy with the solutions that the community has provided to us. So in that sense, thanks very much. We really appreciate the efforts. And with that, I'm through.
Thank you, Peter. So time is over. Quota is out, you told us. So you must have much money for storage in this time.
Always just in time.
Any questions to Peter?
Okay, two questions. Ceph, we didn't have Ceph instance at the time. Dcache is the established mass storage solution, so what would be more logical for us to use that the same way that CERN does EOS? And the second one, why don't we use EOS? Well, we already have Dcache, so why put in a second system? Mainly that.
Thank you. And may I, Luca?
So how do you solve the problem of the synchronization of the files of cache?
With a lot of patience. Yeah. So increasing the memory on the machine that does the syncing job. That's basically it. Okay.
So thank you, Peter. And